Today we're going to talk about angles and degree measures. In order to do this, we're going to do a little bit of a review, probably in every section during trigonometry, of concepts learned in your geometry class. So in geometry, you probably spent a lot of time on angles. Well, you know by definition, an angle consists of two rays with a common endpoint, and that common endpoint is known as the vertex. What you may not have been told is that the two rays have names. We're going to call one of the rays on the angle the initial side. Initial meaning starting ray. And we'll call the second ray the terminal side, or your ending ray. And then the angle is the measure between those two rays. In geometry, we probably found it using a protractor. And what we call that angle kind of depends. Most of the time we call it the Greek letter theta. However, we also will use the Greek letter alpha, which looks like a little fish, or the Greek letter beta, which looks like a bee, but with a little longer leg at the bottom. The measure of an angle is going to give us information concerning the direction of the rotation and the amount of the rotation necessary to move from the initial side of the angle to the terminal side. So we're going to start with this. We're going to call a counterclockwise direction. This is our counterclockwise direction. We're going to call that our positive angle measurements. And then if we go around in a clockwise direction, this direction, we're going to call that our negative angle direction. We're going to be working with angles that lie on the coordinate plane. So we're going to start by talking about an angle in standard position. An angle in standard position means we're going to start with our initial ray on the positive x-axis. The initial ray will always be on the positive x-axis. So we'll start there, and then our terminal side will be somewhere else. And the angle measurement will always be the number of degrees from the initial, and we'll call that terminal, to the terminal. If we're moving in a counterclockwise direction, our angle will be positive. But if I start at my initial ray and instead I go clockwise to get to the terminal ray, that will be in a negative angle direction. Not all angle measurements are dealt with in degrees. Oftentimes, there are people, such as people who work in navigation of airplanes, boats on the ocean, who also use minutes and seconds. So the notation for minutes will be like one little slash. So up at the top that says 60 minutes. And if you have the two slashes like quotation marks, that will refer to seconds, as opposed to this symbol, which we know is degrees. As a matter of fact, we're going to be able to find these symbols on our calculator, which is going to help us out in a little bit, because I'm going to show you how to convert between degrees and degrees, minutes, and seconds, and vice versa. So if you press second apps, you will get to this function called the angle function. I want you to notice that number 1 is the degree symbol, and number 2 is the minute symbol. The other function we're going to use in a little bit is number 4. DMS stands for degrees, minutes, seconds. So if you have an angle in degrees, decimal degrees, and you want to change it to degrees, minutes, seconds, we're going to use that. However, I want you to notice that the second marker is not there. That's okay, because we're going to use the quotation, which I want you to notice is the green little slashes above the plus sign. That means you're going to have to press alpha plus to get the little slashes for the seconds. So let's do an example where I show you mathematically how to computate degrees, minutes, and seconds if you are given degrees in decimals. So example 1 says at a certain time during a flight, an airplane is on an east-west line between two signal towers. If the bearing from the plane to tower A, that means the number of degrees, is 329.125 degrees, change it to degrees, minutes, and seconds. The easy part is the beginning. It's going to be that 329 degrees. What we're going to do is we're going to take the decimal component and change it to minutes and seconds. Well, this is how we do it. Now to go from the decimal degrees to minutes, we're going to take that 0.125 and we're going to multiply it by 60 minutes. When we do that, we're going to get 7.5 minutes. All right, so now we're going to take the whole number part, and that's going to be our minutes. And now we're going to take the decimal part and change that to seconds. So now we're going to take the 0.5 and multiply it by 60 seconds. So 0.5 times 60 is going to be 30. So in degrees, minutes, seconds, 329.125 degrees is going to be 329 degrees, 7 minutes, and 30 seconds. However, if you want to just do this on your calculator, you could have just typed in 329.125 and then go back to that angle function on your calculator, second apps, number 4, DMS, and then hit enter, and it will pop up on your calculator as 329 degrees, 7 minutes, and 30 seconds. What if we want to go the other direction, though? So in part B, it says if the bearing from the plane to tower B is 35 degrees, 12 minutes, 7 seconds, write the bearing as a decimal rounded to the nearest thousandth. Remember, the thousandth place is 3 numbers to the right of the decimal. So we're going to start and do this backwards. So in the previous problem, in order to change it to degrees, minutes, and seconds, we kept multiplying by 60. So if we're going to go the other direction, what's the opposite of multiplying? Dividing. So we're going to start with the 7 seconds, and we're going to divide it by 60. And 7 divided by 60 is approximately 0.117, because you get 1, 1, and 6 repeating. Now we're going to take this number, we're going to tack it onto the 12. So now that means it's 12.117 minutes. Well, now we have to take those minutes and change it into degrees. So now we're going to take that and divide it by 60. And when I do, I'm going to get approximately 0.202. So the final answer is going to be 35.202 degrees. However, your other option for having done this is you could have typed into the calculator the 35 degrees, 12 minutes, 7 seconds by using that second apps function where number 1 was degrees, number 2 was minutes, and alpha plus sign is where your seconds are, and then if you hit enter, it'll just change it into 35.202 for you. When we start with a ray in standard position, when we start with our initial ray on the positive x-axis, if any of our terminal rays end up on an axis, like here at 90 degrees, or here at 180 degrees, or here, if you add another 90, you'll be at 270 degrees. We're going to call that a quadrantal angle. A quadrantal angle is one whose terminal side lies on an axis. If you go a full circle, you'll have gone 360 degrees. And we know that from geometry, that a circle is 360 degrees. We're going to keep that in the back of our head now for the remainder of this section and chapter. In example 2, it says give the angle measure represented by each rotation. So 9.5 rotations clockwise basically means if you go 9.5 circles clockwise, where will you be? At what degree measure? Well, first of all, clockwise is our negative angle direction. So every time you go in a circle clockwise, you will have gone negative 360 degrees. All you have to do is multiply that by 9.5, and it'll give you the degree measure. And you're going to get negative 3,420 degrees. How about 6.75 rotations counterclockwise? Well, counterclockwise is the positive direction. So that means you go 6 full circles plus another 3/4. So all you have to do is take positive 360 and multiply it by 6.75, and it'll tell you that you will have gone 2,430 degrees. The next type of angle we're going to talk about is something called a coterminal angle. Coterminal angles are two angles in standard position that have the same terminal side. Let me show you. So let's say you start on the positive x-axis and you stop here at 30 degrees. Remember, 30 degrees is the number of degrees from the initial to the terminal side. Well, what if I go around in a full circle and then I go and stop at that terminal ray? Well, wouldn't I have gone 30 degrees plus another 360? In which case I would be at 390 degrees. 390 degrees and 30 degrees are called coterminal angles because their terminal ray is in the same location, even if the angle measurement is different. You can also go the other direction. What if I start at my terminal ray, or my initial ray on the positive x-axis, and I go in the negative direction and then stop here? Well, wouldn't it be 30 degrees minus 360, which is negative 330 degrees? So negative 330 degrees is in the same location as 30 degrees and 390 degrees. So now those three angles are all coterminal. And you can keep going around in a circle either clockwise or counterclockwise and keep getting really larger numbers or smaller numbers that land in the same location. So it's very easy to find coterminal angles because if you think back to this problem again, all I did was either add 360 or subtract 360. In example 3, it says identify all angles that are coterminal with each angle. Then find one positive and one negative angle that are coterminal with the angle. Let me start with the second part. 86 degrees. To find a positive coterminal angle, you can add 360. So 86 plus 360 is going to be 446 degrees. To find a negative coterminal angle, you just subtract 360. So 86 minus 360 is negative 274 degrees. Now let me go back to the first one that said identify all angles that are coterminal with each angle. All the angles are going to be 86 degrees plus 360K, where K will be the number of rotations around the circle. So if you go 2 rotations counterclockwise, K would be 2. If you go 3 rotations clockwise, K would be negative 3 because clockwise is the negative direction. Let's do this again in B. In order to find one positive and one negative, you would add 360 and you'll subtract 360. And then all the angles coterminal with 294 would be 294 plus 360K. So 294 plus 360 is going to be 654 degrees. And 294 minus 360 is going to be negative 66 degrees. Example 4. If each angle is in standard position, determine a coterminal angle that is between 0 and 360 degrees. State the quadrant which the terminal side lies in. Let's do a quick review here. If we start, our initial ray is on the positive x-axis, and our angles go positive direction is counterclockwise. Then quadrant 1 are all the angles between 0 and 90. In quadrant 2 will be all the angles between 90 and 180. Quadrant 3 will be all the angles between 180 and 270. And quadrant 4 will be all the angles between 270 and 360. So in order to find an angle between 0 and 360, the first thing I want you to do is look at the number you're given. You're given 595 degrees, which is bigger than 360. That means I'm going to need to subtract 360 to get something smaller. And every time, we're always going to go in a complete circle, so you will always either add or subtract 360. So 595 minus 360 is 235 degrees. Oh, 235 degrees, that is between 0 and 360. And if I look now at this coordinate plane, 235 is between 180 and 270, so it must be in quadrant 3. Let's do that again with negative 777 degrees. Well, I want you to notice that's a really small number. So to get a positive, I'm going to have to start adding 360. The thing is, though, I want you to notice that when you add 360, you're still negative. So you're going to do it again. And you're going to keep doing it until you get a positive number. So now I'm at negative 57 degrees, so I'm going to add 360 again. And this time when I add 360, I get 303 degrees. All right, so now I have an angle between 0 and 360. If I look at this coordinate plane, 303 is between 270 and 360, so it must be in quadrant 4. Oops, sorry. Let's move that up, and there's my box. The last thing that we're going to talk about is something called a reference angle. A reference angle, which is not the same as a coterminal angle, is going to be the acute angle. Remember, an acute angle is one that is less than 90 degrees, formed by the terminal side and the x-axis. So let's start with the first angle I wrote over on the left, 33 degrees. 33 degrees would be in quadrant 1. The reference angle is how many degrees it is between it and the x-axis. Well, the initial ray is always at 0 degrees, so the difference between 0 and 33 degrees is 33 degrees. 161 degrees would be somewhere in quadrant 2. If the reference angle is the acute angle formed between it and the x-axis, which is here, well, here the x-axis is 180 degrees. The reference angle will be the difference between those two numbers, which will be 19 degrees, because that's what 180 minus 161 is. 250 degrees will be somewhere in quadrant 3. The reference angle will be this angle here, between it and the x-axis. So, if this is at 250 and the x-axis is at 180, 250 minus 180 is going to be 70 degrees. So the reference angle must be 70 degrees. 340 is somewhere here in quadrant 4. And then here's the x-axis that's closest to it. So the reference angle must be between 340 and, we're not going to say 0 this time, we're going to say 360 because we're closer to the full circle. So the difference between 360 and 340 is, I don't know what I'm writing here. Let's try that again. 20 degrees. The reference angle will always be an angle that's less than 90 degrees. It's always the angle between the terminal ray and the x-axis, not the y-axis. I don't care how close it is to the y-axis, it's always with the x-axis. And all you have to do is subtract your terminal ray with the number of degrees at the axis. So you're either using 0, 180, or 360. Last example, let's find the measure of the reference angle for each of these angles. So first I want to figure out where each angle is located. So 312 degrees, that's an easy one. It's going to be in quadrant 4. That means I want to find the difference between it and 360. So we're going to subtract those, and I'm going to find out that it's 48 degrees. But negative 195 degrees is a little bit trickier. So it might be easier for you if you dealt with this angle as a positive angle and not a negative angle. Not positive 195 though. What we're going to do is we're going to add 360 to this and find its coterminal angle. So negative 195 plus 360 is 165. That means that these two terminal rays are in the same location. So now let's ignore negative 195 and deal with 165. Where would 165 be? Well, it's going to be in quadrant 2. Yep, shoot, I want to use a different color. Let's try that. There we go. So if this is where 165 is, and it's closest to 180, I'm going to subtract those two angles and find out the reference angle is 15 degrees. Now, you didn't have to do it that way. You could have gone, oh, that's 0 degrees, so that must be negative 90 degrees, so this is negative 180 degrees. So in that case, you could have gone, oh, well, negative 195 would have been here in quadrant 2 because it would be past at negative 180. But I don't think that that's the best way to deal with it in my many years of teaching this topic. I feel that it would be best for you if you find a coterminal angle that's between 0 and 360 degrees, and it will make it easier to deal with. And that is section 5.1 on angles and degree measures.